Good day, everyone. To all my colleagues and to our prof, Mr. Danny Omoso, good afternoon. Our group was assigned to discuss about topic number 4, which is inferences, the beyond descriptives, making inferences based on your sample. Next, please. We divided our group into two. The first group is in charge in preparation of our PowerPoint presentation. They are Mr. Dranbeb Avenido, Miss Eileen Talbo, Miss Marinette Gomez, Mr. Waterford Barnakea, and Mr. Raul de la Cruz. The second group is in charge to discuss the topic. They are Mr. Joel Fulache, Miss Isa Malonzo, Mr. Michael Navarrete, Miss Mylene Joy Molina, and yours truly, Mary Ann Alden. The first to discuss is about inferences to be reported by Mr. Joel Fulache.
Thank you, Ms. Alde. For this topic, we will find out the difference between inferential and descriptive statistic. In inferential statistic, is the process to make inference about the qualities or characteristics of the population that our sample present. It also drawn conclusion about the population based on the findings from the single study with a sample from the population. Interested or variables or factors in the population rather solely in the information we have gathered from the sample. It also used to describe descriptive statistics from our sample to make assumption about particular population from which our sample is drawn. Also based on probability theory, which examine a random event such as roll of dice or toss of coin. When the random events are repeated, they then establish a pattern. So let's discuss this. The inferential statistic used to say something about a large group is called population. Using information collected from the small parts of the population is called a sample. So gagamit tayo ng sample to say something about our population. Sa imperial statistic, but before we go there, let's ask first to define the population and a sample. Population is the entirety of a group including all members that form a set of data. When you talk about the population, ito yung kabuuan na pinag-uusapan natin. Lahat ng member ang pinagkukunan natin ng data. That is called population. Halimbawa, sa buong strand or sa buong school, ang pagkukunan natin ng population. In sample, contains a few member of population. Sample were taken to represent characteristic or trails of the population. From the entire population, kukuha lang tayo ng sampling. Ito yung member na nagre-represent as a sample. Kung may tatanong kayo bakit kailangan natin kumuha ng sample, kasi kung masyadong malaki yung population, it will take you a lot of time and resources para makuha natin yung data sa lahat. Kaya kukuha tayo ng sample as representative ng buong population natin. Yung characteristic and traits nung sample, yun yung magiging characteristic or traits nung ating population in that specific study. So sa descriptive statistic naman, used to something or describe a set of information collected. It can also be represented by a graph. The keyword describe, sinasabi natin gaano kataas o kababa yung data set natin or gaano karami yung isang data kumpara sa kabila, and we are involved one specific population na pinagkukunan natin ng impormasyon. To summarize, ang descriptive statistic ay yung concern lang natin sa isang grupo lang ng tao. Dinidescribe natin kung kumukuha lang tayo ng data about them. Pero ang imperial statistic, gumagamit tayo ng sample for the population. In reliability theory, in probability theory, imperial statistics are based on probability theory, which examine a random event such as roll of dice or toss of coin. When random events are repeated, they then establish a pattern. It's also used to determine how likely in there are coin toss resulting would have occurred in our particular circumstances. Researcher makes discussion based on the probability of a finding occur within certain circumstances. Example, sa probability in tossing a coin. So pagtayo ng hagis ng isang coin, meron siyang dalawang probabilities. Posibleng mangyari ang heads will appear facing up or tail facing up. In tossing a coin, this a random experiment. Bakit siya sabing random? Experiment kasi random, dalawa yung posibleng maging result. So, possibility even while happen is equal to number of desired outcome over the total number of outcome. Pag tinanong natin, ano yung probability? When the heads upon tossing a coin, there will be one is a desired outcome mo na lumalabas yung head. Ano yung total number of outcome? Is yung 2. Kasi dalawang possible outcome ang mangyayari, pwedeng heads or tail. So, sa probability is a branch of mathematics concerning number description of how likely an event is occur, or we measure likely containing event will occur. That's all for my topic for today. To continue our discussion, may I call Ms. Aisa Malonzo for the next topic.
Thank you, Mr. Pulache. So moving forward. Next, please. So what is hypothesis testing? Hypothesis testing is the process of determining whether this statement is supported by the results of the research. It is also a process that includes the use of inferential statistics and allow us to determine when the difference in time and detours are not likely to be due to chance alone. Hypothesis testing is one of the most fundamental purpose of statistical analysis. Researchers commonly need to test hypotheses about a set of data. For example, she might want to test whether one set of data comes from the same distribution as another, or whether the mean of a data set significantly differs from a particular value. Next, please. So under hypothesis testing, there is what we call null hypothesis and alternative hypothesis. For null hypothesis, it is a statistical hypothesis in which there is no significant difference exists between set of variables. So the independent variable does not affect the dependent variable. It is represented by H0. And a null hypothesis can be rejected, but it cannot be accepted just on the basis of a single test alone. Next, please. While on the other hand, for the alternative hypothesis, it states that there is a significant difference between the set of variables, meaning independent variables affect the dependent variable, and it is denoted by H1. The acceptance of alternative hypothesis depends on the rejection of the null hypothesis. Example, until and unless null hypothesis is rejected, an alternative hypothesis cannot be accepted. So just to compare the null hypothesis and alternative hypothesis, so for the meaning, for the null hypothesis, there is no difference exists between the group being compared. But for alternative, predicting that a significant difference exists between the groups being compared. For the null hypothesis, there is no relationship between two variables. However, for the alternative hypothesis, there is some statistical significances between two measured phenomena. For example, children who attended academic after-school program have the same intelligence level as other children, while on the other hand, children in academic after-school program will be more intelligent than children in the general population. And based on the represented, some observed effect on the alternative testing. Next, please. On the null hypothesis, it is what the researcher tries to disprove, while on the alternative hypothesis, it is what the researcher tries to prove. The acceptance, no change in opinions or actions. On the alternative, with changes in opinions or action. For the null hypothesis, the testing is indirect and implicit, while for the alternative, it's direct and explicit. The observation is based on the result of chance only for the null hypothesis, while for the alternative, it's the result of real effect. The denoted by null hypothesis is H0, while for alternative, it's H1. And in the mathematical formulation for null hypothesis is equal sign, while an equal sign for alternative. Next, please. So this is just a key difference between null and alternative hypothesis as mentioned earlier. A null hypothesis is a statement with no relationship, while the statistical is significantly between two measured phenomena. A null hypothesis tries to disprove, while the alternative hypothesis wants to prove. A null hypothesis, no observed effect, while alternative, some observed effect. In null hypothesis is accepted, no chances will be made in the opinion or action. Conversely, if the alternative hypothesis is accepted, it will result in the changes in the opinion or actions. Next, please. Also, in null hypothesis, it refers to population of parameter. Testing is indirect and implicit, while for the alternative, testing is direct and explicit. For the null, it's labeled at H0 and H1 for alternative. The mathematical formulation is equal sign for the null, and alternatively is the not equal sign. In null, the observations are the outcome of chances, while for alternative, outcome of real effect. Next. So the conclusion, there are two outcomes of statistical tests. First, a null hypothesis is rejected and an alternative hypothesis is accepted. Second, null hypothesis is accepted on the basis of the evidence. In simple term, a null hypothesis is just opposite of alternative hypothesis. Next, and then under alternative hypothesis, there is what we call one-tailed hypothesis and two-tailed hypothesis. For the one-tailed hypothesis, this is also known as directional or one-sided test because you can test for effect in only one direction. When you perform a one-tailed test, the entire significant level percentage goes into the extreme end or in the one end only. There is advantage and disadvantage of the one-tailed hypothesis. One-tailed tests have more statistical power to detect an effect in one direction than a two-tailed test with the same design and significant level. One-tailed tests occur most frequently for studies where one of the following is true. It can be effect can exist in only one direction. Also, effect can exist in both directions, but the researcher only care about an effect in one direction alone. The disadvantage of the one-tailed test is that they have no statistical power to detect an effect in the other direction because they are focused alone on the one-sided of the equation. On the other side, the two-tailed hypothesis is also known as non-directional or two-sided test because you can test for effect in both direction or in both ways. When you perform a two-tailed test, you split the significance level percentage between both tails of the distribution. Advantage of two-tailed test is you can detect both positive and negative effect. Two-tailed tests are standard in scientific researches where discovering any type or effect is usual of interest to researcher. So just an example, children in academic after-school program will be more intelligent than children in the general population. That's for the one-tailed hypothesis. On the other hand, for the two-tailed hypothesis, there is academic program would be expected to have either higher or lower IQs, but not the same as IQs as the general population of the children. That's all for my topic. So I will turn the floor to Ms. Navarrete.
Thank you, Miss Aisa. So to continue the presentation, so the error in the hypothesis. So hypothesis testing. Hypothesis testing is to establish, approve, and or reject a particular hypothesis. So there are two types of error in the hypothesis testing. So one type error, also known as alpha error, occurs when first when we reject our null hypothesis, but the hypothesis is correct. This case is also known as a false positive, and the other error is the also known as a beta error, occurs when only a fail or remove the null hypothesis. When the null hypothesis is incorrect, the alternative hypothesis is correct. In this case, is also known as a false negative. The next one is the measuring the effect. So the objective of this effect size is to standardize the measure of size of a particular effects. In this case, so a hypothesis test evaluates the statistic significant or the result of each study, research study. Tests determine whether or not is likely that the obtained sample means occur without any contributions from the treatment effects. And then the hypothesis test is influenced not only by the size of the treatment effect, but also the size of the sample effect. And even the small effect can be significant if it's observed in a very large sample. Because of a significant effect does not necessarily means that a large effect is recommended, that the hypothesis test is accompanied by the measure of the effect size. We use Cohen's D as a standard measure of the effect size. So in this example, so an effect size shows a significant interruptible number of important because of the size allow us to compare the effects both within the across the study. We need an effect size to measure, to estimate. So a power of hypothesis test is the process of hypothesis testing. Is a significant part of the influence statistics. Its purpose is to test a belief or claim. The process of hypothesis testing rely on the sample chosen from the population. So the power of hypothesis test is defined as a probability that the test will reject the null hypothesis when the treatment does have an effect. So the power of the test depend on the variety of factors, including the size of the treatment effects and the size of the sample. So to continue the presentations, may we call on Ms. Mylene Joy Molina to discuss the next topics about the t-test.
Thank you, Mr. Michael Navarrete. So for my discussion is t-test. So for t-test, this is the statistical test that is used to compare the means of two groups. So this is for the significance difference between two groups and how they are related. T-test is also the different types of statistical testing used for hypothesis testing. This is more the conservative approach and more suited in smaller groups on data. So for the key takeaways for t-test can be independent or dependent. And also in t-test, this requires three fundamental data values, including difference between mean values from each data set and standard deviation of values. So next slide, please. Yes. So there are three types of t-test. One is paired sample t-test, two sample t-test, and one sample t-test. So for the paired sample t-test, this is also known as dependent t-test. This test is whether the mean values of two dependent groups differ significantly from each other. Well, the two sample t-test is an independent t-test that tests whether unknown population means of two groups are equal or not. One sample t-test, which is also a test whether unknown population mean is different from this specific value. So there's a sample here, which you can see the difference of the different types of t-test. So next slide, please. Okay. So one sample t-test, the example is for this formula. A company wants to test to claim that their batteries last more than 40 hours using a simple random sample of 15 batteries, yielded a mean of 44.9 hours with a standard deviation of 8.9 hours. This test claim using the significance level of 0.05. By using the one sample t-test formula on the next slide. On the next slide, 40 will be the 40 hours is the population mean. The 15 batteries is the sample size, while the 44.9 is the sample mean, and 8.9 is the standard deviation. So when this is calculated, the p-value is equal to 0.026. Which is lower than the significance level of 0.05, that's why in this t-test sample, the 0.026 is rejected since based on the below paragraph that if p-value is greater than significance level, they will reject it. And if the p-value is lower, the significance level, we will fail to reject. So last is for the t-test, the difference of the t-test to sample test is when the two data samples are statistically independent, while the one sample is it has only one statistical data. So that's all for my report. So next is for Ms. Alde to summarize the whole report. Yan. Okay na po.
Thank you, Ms. Molina. Again, good afternoon. You heard all the report of my group mate. Summarize or give you your takeaway for this topic. Give additional information. When using inferential statistics, excuse me, you will determine whether the finding of study is unusual. It allows us to accomplish this goal more quickly than conducting the identical study multiple times with samples from the same population. Most of the time, you can only acquire data from samples because it is too difficult or expensive to collect data from the whole population that you're interested in. I discussed also the difference of inferential and descriptive statistics. The descriptive statistics focus on describing the visible characteristic of a data set. For example, a chart or graph, a population or sample. And inferential statistics focus on making predictions or generalization about a larger data set based on a sample of those data. Inferential statistics also on probability theory. It is the branch of mathematics concerned with the analysis of random phenomena, or it is the outcome of a random event cannot be determined before it occurs, but it may be one of the several possible outcomes. The actual outcome is considered to be determined by chance. Next was hypothesis testing. It is the process of determining the probability of obtaining a particular result or set of results. It is used to assess the plausibility, acceptability of a hypothesis by using sample data. Such data may come from a larger population or from a data generating process. We discussed also the two different hypotheses, which are the null and alternative hypothesis. Null hypothesis implies a statement that expects no difference or effect. On the contrary, an alternative hypothesis is one expect some difference or effect. There are also two ways to state our hypothesis. These are the one-tailed, two-tailed hypothesis. One-tailed hypothesis is allow for the possibility of an effect in one direction. Two-tailed test for the possibility of an effect in two directions, positive and negative. Framework of hypothesis test, there are two types of error, type 1 error and type 2 error. A type 1 error occurs if a true null hypothesis is rejected, a false positive, while a type 2 error occurs if a false null hypothesis is not rejected, a false negative. For examples of type 1 errors, let's look at the trial of an accused criminal. The null hypothesis is that the person is innocent, while the alternative is guilty. A type 1 error in this case would mean that the person is not found innocent and is sent to jail despite actually being innocent. And examples of type 2 error, a test for a disease may report a negative result when the patient is infected. This is a type 2 error because we accept the conclusion of the test is negative, even though it is incorrect. And on the last topic about t-test is the statistical test that it used to compare the means of two groups. And there are three types of t-tests. These are one sample t-test, two sample t-test, and paired t-test. One sample t-test is a statistical hypothesis test used to determine whether an unknown population mean is different from a specific value. Next is the two sample t-test. It is a method used to test whether the unknown population means of two groups are equal or not. And then lastly, the paired t-test. It is the statistical technique that it used to compare two population means in the case of two samples that are correlated. Example for this is, suppose we want to know whether or not a certain training program is able to increase the maximum vertical jump in inches of college basketball players. To test this, we may recruit a simple random sample of two college basketball players and measure each of their maximum vertical jumps. Then we may have each player use the training program for 1 month, then measure their maximum vertical jump again at the end of the month. to determine whether or not the training program actually had an effect on maximum vertical jump. We will perform a paired sample t-test. So that's all for our topic about inferences. Again, good afternoon. And in behalf of my group mate, thanks to all of you. Thanks for listening.